Good day, grade 10 math enthusiasts! Are you ready for another journey of learning? Again, I'm teacher Mariam B. Millanes, who will talk about geometric sequence. At the end of the topic, you are expected to: number 1, illustrates a geometric sequence. Number 2, differentiates a geometric sequence from an arithmetic sequence. Don't forget to bring out your pen, paper and notebook, and self-learning modules. Let's begin with the first activity. Am I arithmetic or not? Identify whether the given sequence is arithmetic or not. Write AS if it is an arithmetic sequence, otherwise write NA. Explain why the others are not considered as an arithmetic sequence. Remember, an arithmetic sequence is a sequence obtained by adding or subtracting a constant term from one term to another, and it is called as common difference. Number 1, 28, 24, 20, 16, and so on. Hooray! This is an arithmetic sequence. From one term to another, you subtract 4. 28 minus 4 is 24, 24 minus 4 is 20, and finally 20 minus 4 is 16. Number 2, 5, 20, 80, 320, 1280, and so on. Yes, this is not an arithmetic sequence. Why NA? Because we multiply 4 from one term to another. 5 times 4 is 20, 20 times 4 is 80, 80 times 4 is 320, 320 times 4 is 1280. Number 3, 2,500, 500, 100, 20, and so on. Yes, the answer is also not an arithmetic sequence. Why? Because we divide 5 from one term to another. 2,500 when divided by 5, the answer is 500. 500 divided by 5 is 100. And when you divide 100 by 5, the answer is 20. Number 4, 15, 27, 39, and so on. That's right, this is an arithmetic sequence. It is because we add 12 from one term to another. 15 plus 12 is 27, and 27 plus 12 is 39. And lastly, number 5, 2, 12, 72, 432, and so on. Yes, this is not an arithmetic sequence because from one term to another, we multiply 6. The following sequences, which are not considered as arithmetic sequences, are all examples of geometric sequences. Number 2, number 3, and number 5. How do you now define geometric sequences? Geometric sequences are sequences obtained by multiplying a common ratio to the preceding terms in order to obtain the succeeding terms. The constant term you multiply or divide from one term to another is what we call as the common ratio, represented by small letter r. If you multiply, use whole number as your common ratio. If you divide, use fraction. Let's talk about activity number 2, missing in action. Identify the value of the missing term in each geometric sequence. Number 1, 28, 14, blank, 7 over 2, and so on. In this case, we need to get the common ratio first before getting the missing term. In order to identify R, choose any two consecutive terms from the sequence and divide from right to left. Suppose I will choose 28 and 14. So we will write it as 14 over 28. But 14 over 28 is reducible to lowest term. And the lowest term for it is 1/2. The missing term now is 14 times 1 over 2. Just multiply 14 with your numerator and then divide it by your denominator. 14 times 1 is 14, divided by 2, that is 7. So the missing term is 7. Number 2, 3, 12, 48, blank, and so on. So first step, identify R. In this case, I will choose 48 and 12. 48 divided by 12 is 4. You can also choose 12 and 3. 12 divided by 3 is also 4. So the common ratio here is 4. To get the missing term, multiply the term beside the blank by your common difference. 48 times 4 is equal to 192. Number 3, negative 4, 8, negative 16, 32, blank, 128, and so on. First, identify R by choosing consecutive two terms from the sequence and divide from right to left. In this example, I want to choose 8 and negative 16. So your R equals negative 16 divided by 8, and that is equivalent to negative 2. Even you choose negative 4 and 8, 8 divided by negative 4 is still negative 2. Even when you choose 32 and negative 16, 32 divided by negative 16 is negative 2. So the missing term now is 32 times negative 2 equals negative 64. The term after 32 is negative 64. Let us now relate geometric sequence to real-life scenario. Let's read our problem. In Math Nation channel, you are amazed in grade 10 videos and discover that they are very helpful in your study. You shared this to your friends. At 9 a.m., you shared the video to 2 persons. Then at 10 a.m., each of your friends shared it to another 2 persons. Illustrate the pattern up to 4th cycle if it keeps on going. Using pictures to illustrate the problem, you started with 1 person and that is you. You are amazed with the videos in Math Nation channel, and since it helps you in your study, you shared it to your 2 friends at 9 a.m. So on the 2nd cycle, there are 2 persons in which you shared the videos. Each of your friends shared also the videos to 2 of their friends. So on the 3rd cycle, there are 4 persons in which the videos were shared. And finally, each of those 4 persons also shared the videos to 2 of their friends. That's why in the last cycle, which is the 4th cycle, there are 8 persons in which the videos were shared. To list the sequence, we get 1, 2, 4, 8, and so on. By using the list of terms, we will now use a table in order to show how did we obtain the given terms. For a sub 1, the term is 1, a sub 2 is 2, a sub 3 is 4, a sub 4 is 8. In a sub 1, we have only 1 person since we do not share the videos yet. But in a sub 2, from 1 person after sharing it to 2 persons, we have 1 times 2, and that is equivalent to 2. For a sub 3, each of your 2 friends also share it to another 2 friends. So 1 times 2 times 2, and that is 4. And for a sub 4, we have 1 times 2 times 2 times 2, since your 4 friends shared it again to another 2 persons. The representation in the third column in obtaining the terms can also be transformed into exponential form. Let r be equals to 2. So 1 times 1, that will be 1 times 2 raised to 0. Any number raised to 0 is 1. For 1 times 2, we have 1 times 2 raised to 1. For 1 times 2 times 2, that is 1 times 2 raised to 2, since we multiply 2 by itself twice. And lastly, for 1 times 2 times 2 times 2, that is 1 times 2 raised to 3. Compare now your subscripts n to the exponent. What do you notice? That's right, the exponent is equal to n minus 1, since the exponent is 1 lesser than your subscript. Therefore, for any geometric sequences, the general term is a sub n equals a sub 1 times r raised to n minus 1, where a sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. To summarize, let us now differentiate arithmetic sequence from geometric sequence. Arithmetic sequence is obtained by adding or subtracting a constant term to the preceding terms in order to obtain the succeeding terms. Remember, adding or subtracting a constant term to the preceding terms. While geometric sequence, this is obtained by multiplying and dividing a constant term to preceding terms in order to obtain the succeeding terms. Again, multiplying and dividing a constant term to the preceding terms. In addition, the constant term added or subtracted from one term to another in an arithmetic sequence is called common difference, while in geometric sequence, the constant term multiplied or divided from one term to another is called common ratio. In terms of the general term, arithmetic sequence has a general term of a sub n equals a sub 1 plus quantity n minus 1 times d, whereas the general term of a geometric sequence is a sub n equals a sub 1 times r raised to n minus 1.